Hello and welcome to the presentation of the DAS1700. This high-speed data acquisition solution is a top-of-the-range multi-purpose instrument developed and manufactured by Sefram in France. It has a 15.4-inch color touchscreen display and you can record from 6 to 72 channels depending on the selected board. Its internal solid-state memory is 500 GB standard with an option of 2 TB. Now let's take a look on the top panel. We have different interfaces. We have a LAN port to connect the instrument to a network and pilot it remotely. We have 4 USB ports to connect a USB stick to retrieve recorded data, but you can also connect a keyboard, a mouse, or even a printer. You have a VGA output to get a copy of the instrument screen on a remote monitor, and finally a SUBDIP25 connector for the 16 logic inputs and the alarms outputs. We can notice the device has a carry handle that allows you to use the DAS1700 in different positions. Now let's focus on the acquisition boards. The DAS1700 has 3 board slots. An optional extension is available to provide an additional 3 slots. Its customizable configuration will suit most of your applications. We have 4 acquisition boards: a universal board, a multiplex board, a high voltage board, and a strain gauge board. Now let's detail the features of each one. For the universal board. The universal board is a versatile acquisition board. It has 6 isolated channels, a maximum voltage input of plus and minus 500 volt, a 14-bit resolution and a maximum sampling rate of 1 megasample per second. This board is compatible with DC or RMS voltage and current recording, frequency, temperature with thermocouple sensors, counter, and power analysis. For the multiplex board. The multiplex board is made for the process. It has 12 multiplex channels, a maximum voltage input of 15 volt, a 16-bit resolution, and a maximum sampling rate of 5 kilosamples per second. This board is made for DC voltage and current recording, temperature with the thermocouple sensors, resistance, and PT measurement with 2, 3, or 4 wires. For the high voltage board. The high voltage board is made for high voltage measurements. It has 6 isolated channels, a maximum voltage input of plus and minus 1000 volts, a 14-bit resolution, and a maximum sampling rate of 1 megasample per second. This board is compatible with DC or RMS voltage, current, frequency, and power analysis on single and 3-phase networks. For the strain gauge board. The strain gauge board is made for mechanical deformation measurements. It has 6 isolated channels, a 16-bit resolution, a maximum voltage input of 50 volts, and a maximum sampling rate of 100 kilosamples per second. This board allows full bridge, half bridge, strain gauge measurements, but also low voltage and current measurements and temperature recording from PT100, 1000 or thermocouples. Now we are going to list all the available options for the instrument. The Wi-Fi option allows to connect the instrument to a Wi-Fi network or a PC to pilot it remotely or retrieve recorded data. You can choose factory options. The battery option allows to use the DAS1700 if the access to a main supply is not possible. The optional extension offers 3 additional boards. IRIG GPS option allows you to synchronize the instrument's internal clock with a GPS or IRIG signal. The CAN-LIN input option allows you to record and analyze CAN-LIN buses. Send options allows you to record send buses and to make PWM measurements. If needed, the instrument can be rack mounted using the optional rack mount kit. Let's see the accessories available for this instrument. The cord for logic inputs and alarms to easily connect the sub-D25 connector of the instrument, the 60 channels isolated logic module to increase the maximum voltage from 24 volts to 250 volts, and in our product line you can also find different current clamps or shunts for current measurements to record 420 mA signal or three-phase system, for example. And finally, accessories for general measurements, like alligator clips, measurement cords, probe tips, and so on. Finally, several softwares are available for free to remote control the device and analyze the recorded data.
Welcome to the DAS1700 homepage. From this page, you can access all the available features of the instrument. User manual. Get direct access to the complete manual in PDF format. Setup. Setup menu is used to set the general parameters of the instrument. Language, network address, software version. Channel. Access the summary table of all acquisition channels. Validity. Select the analog and logic channels displayed on the screen. Logic channels. Access the parameters of the logic channels. Trigger. Set your recording parameters and define trigger conditions. XY. Allows you to visualize the validity channels in real time on screen in comparison with each other. FT. Gives you access to a real-time display of the measurements, like an oscilloscope. Numeric. Visualize the digital values of the validity channels in real time on screen. Replay memory. Access the data acquisition available in the internal memory or in a USB stick. Start-stop. Launch a data acquisition. On the right side of the screen, you can see the different recording modes available. Mode file. Allows to record directly in the internal memory of the instrument. Mode memory. Quick data recording mode that allows to record on the RAM memory and then transfer these recordings into the internal memory. Power analysis. Allows to analyze single-phase or three-phase networks. It can analyze up to 4 networks simultaneously. It allows to measure all types of physical values related to power analysis, such as power, harmonic, current, voltage, and others. Mode Go-No-Go. Allows to record when the threshold limit is exceeded. By clicking on User Manual, you have direct access to the PDF manual of the device. Access the Setup menu to configure your DAS1700. Select the language of the instrument. Set the delay before the backlight is turned off. Set the date and hour of the instrument or access the timestamp setting via NTP or PTP server or via IRIG or GPS functions. Access the Modification Version Options menu to update your instruments or to add an internal software. Access additional options. Bar graph. Reverse the maximum and the minimum of the bar graph. Security. Define passwords for VNC or FTP mode. User mode. Enable or disable this mode to block certain features of the instrument. Keypad locked. Enable or disable this feature to fully lock the keyboard. Calibration. Calibrate the offsets. Email address. Add an email address to receive a notification in case of a trigger or alarm. Text file format. Modify the text acquisition file format. Erase internal disk. Completely erase the internal memory. Network disk. Connect network drives to perform automatic backups on a NAS, for example. On the right side of the screen, you can find the Setup tab with Reset Setup menu, which allows to completely reset the current configuration of the instrument. Save on Disk menu, which allows to save the current configuration in the internal memory of the instrument. Load on Disk menu, which allows to retrieve the configuration made some time ago. On the right side of the screen, you can also find the Network tab to access the various network parameters. For the Ethernet network, enable or disable DHCP mode, set an IP address with its mask or gateway. For the Wi-Fi network, select the SSID you wish to connect to. Finally, through the Alarm tab, you can generate a TTL05 signal depending on the conditions you have set. Enable or disable the sending of mail or the creation of an annotation on the acquisition when the alarm has occurred. The Channels menu gives you a summary table of all channels and their parameters. You can see the name of the channel, whether the validation is active or not, the type, voltage, current, whether there is a filter or not, whether there is a function or not, the range, the center zero, maximal and minimal threshold. Access the complete channel's parameters by clicking on it. Visualize the different channels according to available acquisition boards by clicking on the board type. Visualize the logic channels. The functions allow you to perform calculation between channels or more sophisticated calculation via a function editor. The Validity menu allows to select and validate the channels you wish to display on screen. You can navigate from board to board, activate logic or function channels, and customize your pages to define the channels that will be displayed later. The Logic Channels menu allows to access the parameters of the logic channels. The instrument is equipped with a sub-D25 connector to manage all logic signals. There are 3 alarm outputs: A to C, one 12-volt output for external power supply, and 16 logic inputs. A numbered diagram for your wiring is shown on this page. For each logic channel, you can define the name, the color, and the visual status change when the input changes to 1. You can use the logic input states as a trigger signal for a recording. This setting can be found in the trigger menu. The trigger menu is different according to the current mode: file, memory, power analysis, and go-no-go. Let's study the trigger menu in file mode. To access it, click on File mode. First of all, define in which folder you wish to save your acquisition. You can create a new one, for example. Then, name your file, which will have a .rec extension. You can limit the size of your acquisition file by number of samples. Depending on the defined sampling rate, the recording time will be given in parentheses. Define the sampling rate of your recording. You can choose to make a second recording simultaneously with a different sampling rate by checking Save Secondary File. In this way, you can trigger an acquisition with a higher sampling rate to record particular events. You can also define other channels to be recorded. To set a trigger correctly, a start condition and a stop condition must be defined. The manual trigger will wait for you to press start and stop to start and stop the recording. The analog channel trigger will wait for the condition defined on the analog channel selected to be achieved. Trigger on a positive or negative edge or a level. The combination analog channel trigger will wait for the condition defined on the analog channel selected to be achieved. The logic channels trigger will wait for the condition defined on the logic channel selected to be achieved. Status is changed to 1. Glitches trigger is dedicated to the recording when glitches appeared on signals. You can set a pre-trigger that can be defined in number of samples. It will allow you to visualize what happened before the trigger event. Next menu allows you to define what will happen after the acquisition. Send an email notification, automatically print the results or the curve, or automatically create a text file. You can choose to rearm, which means that when trigger conditions will reappear, a new recording will start. The replay mode allows to visualize the completed recording or copy a recording to a USB key. First of all, click on Files Manage. Then, click on Load File. Select the file you wish to display or copy to a USB key. To copy this file, click on Copy to USB. To display it, click on Load. You are asked whether or not you want to load the configuration used for this recording. Finally, on your recording, you can place cursors, zoom in or out, and so on. Let's take the example of the recording of a sensor, such as a pressure sensor in bar. Let's select the channel we want to configure, A1 for example. Then, let's define the type of physical value we want to record. Here, a direct voltage for a 0-10 volt sensor or a 420 mA sensor. The channel can be automatically configured by pressing External Sensor and selecting 0-10 volt sensor, 420 mA sensor, current clamp, etc. In our case, we will do a manual configuration. Let's name this channel Pressure. You can configure the color and the thickness of the measurement curve. Then, let's activate the change of unit function and define the slope of our signal, x1 and x2 being the voltage values measured by the instrument, and y1 and y2 being the physical values. Let's set the unit in bar. For a measured value of 0 volt, we will have 0 bar, and for a measured value of 10 volt, we will have a measurement of 100 bars. Our change of unit is now set. You can see on the left of the screen that the range is now in bar. Our display range being from 0 to 10 bars, we realize this is not enough since we have set a Y2 at 100 bars. So we need to increase the range to 200 bars, for example. Now let's set the center 0. The 0 being in the center, we have a display from minus 100 bars to 100 bars. So we will set the 0 at the minimum value to have a display from 0 to 200 bars. Now, define the triggering threshold. For example, the first one at 2 bars and the second one at 20 bars. You can see that the warning about the threshold has disappeared. Now, you can copy the configuration of this channel to any other channel that would be identical. Let's see together how to configure a channel. Select the desired channel and access the channel parameters by clicking on it. Define the type of signal you want to record. In our example, we will record a thermocouple, type K, and compensated, with a unit in degrees Celsius. Name the channel. In our case, it will be temperature. Define the color and the thickness of the measurement curve. Now, define the range. In our example, we use a 50 degrees range with a display range of minus 25 degrees to plus 25 degrees. We can change the 0 position to have a display from 0 degrees to 50 degrees, or from 0 degrees to minus 50 degrees, or any other combination. You can set a filter on the channel to cut all frequencies that would be higher than the recorded signal. In our case, we apply a 1 Hz filter in order to cut all frequency higher than 1 Hz. Let's define a threshold at 27 degrees. Above this temperature, the recording will start. Finally, you can copy this configuration of this channel to any other channel that would be identical. Our thermocouple channel is now configured. Let's make a recording test. First, go back to the main menu. Let's uncheck the channel A1, which we do not want to record. Then, select the mod file to save directly in the internal memory of the instrument. Let's define our folder. In our case, we will use the test folder. Then, let's name our file. Office temperature, for example. Let's set the file length and leave it at unlimited to record. The limit being the size of the available internal memory of the instrument. Let's define the sample rate by selecting 5 milliseconds, for example. We do not check Save Secondary File. Now, let's define the start condition of the data acquisition. We choose Trigger and set the threshold to 27 degrees. To sum up, when the temperature of our B1 channel exceeds 27 degrees, the recording will start. The stop conditions will stay on automatic. In this case, you can stop the recording manually, or it will stop automatically when the internal memory is full. We do not define a next state. Now it's time to test our recording. Access the Start-Stop page via the button in the top right of the screen. Let's activate an interesting feature of the instrument: the color change when the threshold is exceeded. To do so, go to the Setup Screen menu, Option, then activate the color change on Threshold Crossing. This way, we will see the threshold we have set is exceeded. Let's carry out our recording. The temperature rises and then stagnates and never reaches the threshold set previously. That means we have a problem with the parameters of our recording. The threshold value is now high compared with the actual signal. Let's fix that. We stop the acquisition, go back to the main menu, go to the channel configuration, and lower the value of our threshold to 25 degrees, for example. Go back to the Start-Stop page via the button at the top right of the screen, and let's test our temperature recording again. We can stop the recording. We can see that there was a trigger and that our signal above the threshold is indeed of a different color. We can analyze this recording directly on the device, for example by setting cursor time. With these cursors, we can also search for the maximum and minimum point of the recording. In our case, the maximum temperature is 26.5 and the minimum temperature is 22.7. Also, you can make mathematical calculation on the results of the data acquisitions. To do so, go to Setup Screen, Common, and select Calculation Validity. You can define this calculation or add other calculations by selecting each time the channel on which we want to perform them. We made a first analysis on the instrument. You can make a screenshot of this first analysis. To do so, press the Screen Copy button in the top right of the screen. The screenshot will be automatically saved on the USB stick if there is one, or in the internal memory if not. For further analysis of the recording, you can export these files to a computer. To do so, two solutions. The first one, copy the file on the USB stick. Go to File Manage, Load File, select the file to export and click on Copy to USB. The file will automatically be copied to the USB stick. The second one, a transfer via FTP server. To do so, the instrument has to be connected to a computer via an Ethernet cable or connected to a network via Ethernet or Wi-Fi. To download a recording via the FTP server, first go to your computer's Windows Explorer and type FTP:// and the IP address of the instrument. Access the internal hard disk of the instrument and then the recording folders. Select the folder and then the file you want to export. Make a copy of it to your computer's internal hard disk. The recording file is now on your computer. It can be opened and analyzed using the Sefram Viewer software. To do so, select the file on your computer. Right-click, Open with and select Sefram Viewer. Validate. You are looking at the recording. You can place cursors or export the file to a .csv file, for example. Pilot Sefram is a free software developed by Sefram. It allows you to configure the instrument remotely and to start or stop a recording. First, enter the IP address of the instrument. The instrument can be connected via Ethernet or Wi-Fi on the same local network. Activate the connection. You are asked if you want to retrieve the current configuration of the instrument. The interest being to modify a configuration that you would have started on the instrument. In our case, we are not going to recover this configuration since we are going to send a new one to the instrument. The device is now in remote control mode, which means it's the computer that controls the instrument. You can visualize the active channels on the instrument, both graphically and numerically. Let's first define the channels we want to enable and disable. In our case, we will disable A1 and enable C1. Our C1 channel is an ambient temperature recording. The type is a temperature measurement via a K-type thermocouple. Then, let's set up a 1 Hz filter. Since this is a temperature measurement, we will cut all frequencies above 1 Hz. Let's define our range by putting a 60 degrees range with a position from 0 to -100% to have a range of display from 0 degrees to 60 degrees. Validate and send this configuration to the device. The device is well configured. We can visualize our signal and we can see it change. Let's now configure the trigger. The parameters are the same as those on the instrument. We can choose the mode. We stay in mod file. Name the recording. And choose between an internal or external sampling rate. Internal meaning it is run within the DAS1700, or external meaning it is synchronized with an external signal. We stay on an internal sampling and put a sampling rate of 200 milliseconds. We can limit the length of the file or record the entire internal memory. We do not set a file limit. We can choose between a manual, a waiting, or automatic trigger. If we choose trigger, there are different types: analog channel, logic channel, or combination analog channel. In our case, we choose an automatic trigger for both start and stop. You can set the next state on rearm or change setup. In our case, we choose to leave it on stop. We validate and send this configuration to the instrument. The instrument is properly configured. We start our recording. The recording starts, the signal varies, and we now stop the recording. The recording is complete and we can instantly visualize it. By clicking on this button, You can save the .reg file directly to your computer's internal hard disk or open it in Sefram Viewer. Once the file is opened, you can analyze it, place cursors or export it in CSV. But let's go back to Pilot Sefram. We still have one last button, the FTP Explorer, which allows us to access the DAS1700 internal memory and to copy and paste the various recordings onto your computer. The VNC Viewer software is free and can be downloaded from the internet. It allows you to have a reproduction of the screen of your instrument on your computer. The instrument has to be connected to your computer via an Ethernet or Wi-Fi connection. In the software, you first have to create a new connection. To do so, enter the IP address of the instrument. Access this connection and enter the password you previously entered in the DAS1700. The computer connects to the instrument and you get a copy of the instrument screen. You can now navigate through the menu and configure the instrument just as you would directly on the device. In this example, we will analyze two electrical networks simultaneously, a main one and a secondary one. First of all, let's connect all the elements, such as current clamps and voltage measuring cords, to the instrument by following the diagrams shown on the instrument display. Then, wearing personal protective equipment, connect all these elements to our electrical installation. Let's now move on to the configuration of our power analysis. Access the power analysis menu and enable double circuit, since we have two networks to record. We can visualize our circuit A and our circuit B. Our circuit A is a star type circuit and its frequency is less than 60 Hz. Let's select a direct voltage. If we had performed an analysis on a high voltage transformer, we could have selected a transformer voltage. The instrument allowing a maximum voltage of 500 volts on this board. We could have chosen a transformer to record a higher voltage. Let's define a nominal voltage of 240 volts. Now, let's move on to the current part. The current can be recorded in different ways, via a clamp, a shunt, or via a current transformer. In the case of a shunt, you can directly enter the value of the shunt in ohms and the dephasing between I and U to have more accurate values. In the case of a current transformer, you can enter the ratio between the primary and the secondary current of the transformer and then the value of the shunt to be able to enter a voltage on the recorder. Let's select a clamp. Our current clamp measures 1 kA for 1 volt. Now that the clamp is configured, we need to set our nominal current. The nominal current of our installation is 200 amps, so we select 250 amps to have a little margin. Now we are going to configure the circuit B. This circuit also has a direct voltage with a nominal voltage of 240 volts. The current will be measured with a clamp, but this time we won't enter a transformer ratio. For this example, we use a SP221 clamp from Sefram. You can configure it directly by clicking on External Sensor. In this menu, all Sefram clamps are referenced. All you have to do is select SP221 and the settings will be made automatically. The nominal current of our installation is 4 amps, so we select 5 amps to have a little margin. Let's now move on to the parameters. To access the configuration of the different parameters, click on one of them on the left side of the screen. It brings you to the parameter page. First of all, you can define the number of parameters. The display can be set from 1 to 61 parameters at the same time. Determine the number of integration periods, which means the number of periods that will be taken to calculate the frequency, RMS values, or the power, for example. Select below the parameters you wish to modify. In our case, parameter number 7 is selected. For example, we can modify it to display a total reactive power on our circuit A. You can also set the parameters itself as you would do on a classical channel. The 0, the maximum display, the minimum display, the triggers. You can also copy this configuration to another parameters. Finally, you can even define the color of the parameters. Let's take a concrete example. Let's select our parameter number 1, which is the voltage in RMS on our circuit A with U1. We know that our voltage is about 230 volts. So, we set a minimum display at 200 volts and a maximum display at 300 volts to limit the scale on our recording. We can also define the triggers. We can now copy this configuration to U2 and U3, for example, and validate. If you go to U2, the parameters of 200 volts and 300 volts have been successfully applied. Let's now move on to the display. By clicking on the FT button in the top right of the screen, you can access the display page to see the different voltages, currents, harmonics, etc. We can see the Fresnel diagrams of our two networks, the different parameters, the curves, and the harmonics diagrams of our circuit A. We can access the display parameters by clicking on the left side of the display oscilloscope. You can set the display of Fresnel diagrams in power factor or cos-phi mode. You can also configure the display oscilloscope to define the number of screens you want to display. We can choose to display two screens to have the voltages on one side and the currents on the other. You can notice that we only visualize our circuit A. To visualize circuit B, select Circuit B in Validity or choose to see both networks. For better readability, let's select only one circuit, Circuit A. Let's move on to the display harmonics. We can choose to display the voltage harmonics of circuit A, the current harmonics of circuit A, both of them or even all the harmonics of the two networks. Range allows to define the display range in percentage or the harmonics diagram. With 10%, for example, we have a harmonic diagram that goes from 0 to 10% of the fundamental. Analyze file allows to manage the parameters of the harmonics analysis file that will be generated during the recording. Finally, you can set the background color and the grid color. Let's move on to our recording. First of all, let's reduce the number of parameters to improve the readability of our recording. To do so, let's go back to the parameters and decrease the number to 11. Now, we will set all the parameters we will record later. We have our 3 voltages on circuit A, our 3 currents on circuit A, our total powers P, Q and S on circuit A, the frequency on circuit A as well, and finally the total power factor on circuit A. Now that the parameters are set, we can start recording. The recording starts, we can stop it and see our different signals. For more readability, we can go in Setup screen to choose to see 11 screens to have 1 screen per setting. We can analyze the recording and visualize if we have a voltage drop or a particular event on the power or on the frequency and so on. The best solution is to export this recording and analyze it on Sefram Viewer, for example. There are several ways to export it, which we saw in the previous chapter. The FTP server, copying it on a USB stick, or using Pilot Sefram.